All right, so let's go on and do these. Let's see, we went through the vocabulary yesterday, so we're done with that. But what I want to do is start going through these free response questions. So if you will, go ahead and open up your notes to these questions. Let's read this one and talk about how to do that. See if you could come up with what would be necessary for the grading guidelines, or talk about what you would need. Okay, so here we go. I'm just going to read it out loud as you kind of look at it. A new type of fish food has become available for salmon raised on fish farms. Your task is to design an experiment to compare the weight gain of salmon raised over a 6-month period on the new and old types of food. So that would be our two different treatments, the new and old types of food. The salmon you will use for this experiment have already been randomly placed in 8 large tanks in a room that has considerable temperature gradient. So look at the picture of the room. Why is there large differences in temperature in this room? Okay, because we got the heater down here, and then we got windows and the door. So there's considerable difference between the temperatures in these tanks. Specifically, tanks on the north side of the room, that's the one by the window and the doors, tend to be much more cold than those on the south side by the heater. The arrangement of the tanks is shown in the diagram below. Describe a design for this experiment on weight gain that takes into account this temperature gradient. Okay, so there's fish in all those tanks. How are you going to decide how to give them the food? Okay, alternate the treatments in each tank. Okay, so like let's label these new, old, or whatever. So okay. Okay, that's good. Okay, so first of all, good. Okay, good. So these are similar in temperature. Would you agree? Tanks 2 and 3 are similar in thing. And then 1 and 4 are similar. Would you agree with that? That those are the comparable tanks. Okay, good. And so let's just identify comparable tanks right now, because we did. I think some people have done this problem. I think there was another one that was the chairs at the, yeah, it was the chairs in the airport and the leather treatment. Okay, so, but I think some people had this one. Okay, so how else? Or how could we compare, what about the bottom row? Okay, so 6 and 7 are comparable in temperature and atmosphere, and then 5 and 8. Okay, good. All right, so how would we describe this? We would group like tanks together. Okay, I like that, how you did that. So 2 and 3, 1 and 4, 6 and 7, 5 and 8. Okay, good. Now, instead of just saying, oh, this one's new and this one's old or whatever, we do need to do what Landon said, and that is randomly assign the treatment. Randomly assign the treatment. So the next thing we're going to do is randomly assign the treatment. And how do you want to do that? Let's describe how we do that. Yeah, I think we could go easier than a random number generator. We only have 2 things here, new and old. And okay, flip a coin. Okay, randomly assign treatment by flipping a coin and the lower number gets the result. I don't know, I just made that up, but the lower number gets the results. Like, okay, so heads equals the new and tails equals the old food. For example, I'm going to come over here and look at group 2 and 3, and I'm going to flip my coin, and ta-da, it was heads. So the lower number, which is number 2, gets what? Okay, so number 2 gets the new treatment, which makes number 3 get the old. Okay, now I'm going to come over here to my 1 and 4, and I'm going to flip my coin. Ta-da, it was heads. So that means that the number 1 gets new, and this one gets old. And then I'm going to continue that for the other 2 groups. Okay. All right, so now what? What do I say after I have now randomly assigned the treatments? Continue, or do we need to say things like feed them at the same time each day, same amount, feed the tanks the same amount, same time each day, and then at 6 months we're going to compare. Okay. So feed tanks the same amount at same time each day, and then after 6 months we're going to compare the groups. Okay. So here's the answer. Let's see how we did. And I didn't I didn't really come up with much. Y'all came up with this, so let's see how you did. Block salmon as follows to account for temp gradient, as temperature might affect weight gain. So remember how I wrote this group like together? I probably should have used a correct vocabulary word here. What could I have done? Yes, how about block? I don't know if I would say pair, because pair would imply like before and after results. Okay? So good. Okay, so block them together. I like what they did here. They said why. So that because temp might affect weight gain. So I like that. They were more thorough with that. They said why. Okay? Randomly assign the treatment to each block by flipping a fair coin. And we didn't say fair coin, but I think we'll be okay. Tank 1 gets the new and tank 4 gets the old. Repeat for other 3 groups. After 6 months, compare weight gain. I thought we were better in that we said feed the tanks the same amount at same time each day. Thought we did better with that than this. They just said after 6 months, compare weight gain. By blocking, temp gradient was equalized. Okay, they said that kind of reinforced that. All right, I think you did a good job on that one. Okay, next. This one I do actually have sample student responses and the real grading guidelines, or scoring guidelines. So, okay. Students are designing an experiment to compare the productivity of 2 varieties of dwarf fruit trees. The site for the experiment is a field that is bordered by a densely forested area on the west or left side. The field has been divided into 8 plots of approximately the same area. The students have decided that the test plots should be blocked. 4 trees, 2 of each of the 2 varieties. So you see all these squares down here? Each one of these squares is going to contain 1 tree. There's 8 trees involved. We have 4 trees of each variety. Okay. 4 trees, 2 of each of the 2 varieties will be assigned at random to the 4 plots within each block. with one tree planted in each plot. Okay. The two blocking schemes shown below are under consideration. For each scheme, one block is indicated by the white regions, and the other block is indicated by the gray regions in the figure. Okay. So the first question, which of the blocking schemes A or B is better for this experiment? Explain your answer. Okay, and why do you say B? Okay, so look at what's going to happen. So I have 4 trees, and I'm going to randomly pick it. Let's say fruit tree type 1 ended up here, and fruit tree type 1 ended up here, which put fruit tree 2, fruit tree 2. Because within this block, I have 4 trees, 2 of each type. That's what this says. Okay, so then I'm going to flip my coin for the next one. What if, just by chance, it ended up fruit tree type 1 went here, and fruit tree type 1 went here, and fruit tree type 2 went here, and fruit tree type 2 went here? Then that's not serving the purpose you want it to, is it? So, because within each block, there are 2 kinds of trees, 2 of each kind. So let's look over here. What happens if I got fruit tree 1? Oh wait, I don't block it that way. This is a block. So what happens if I flip my coin and I put fruit tree 1 here and fruit tree 1 here? What then goes here and here? Fruit tree 2, fruit tree 2. Correct. I mean, it's 2 kinds. So do you see, and I see your confusion, because when I did this the first time, I clearly thought B was going to be it, because, you know, by nature, it seemed like this was going to be all the fruit tree 1s, and this was going to be all the fruit tree 2s. Okay?
Well, I mean, when you flip a coin, you have to put it in the order.
Yes, that's the randomness. So this is not necessarily what's going to happen, but this could happen with the coin flip. So that doesn't make sense. I mean, I don't know. This question's kind of weird because it's intuitive. You know how you want to set them up, but gray is one group of trees. Gray is one group of trees which contains 2 of the type 1 and 2 of the type 2. White is another group that contains 2 of the type 1 and 2 of the type 2.
But they're exactly the same.
What? No, there's 2 types, 4 of each kind. Two of each of the 2 varieties.
I forgot I had it on there.
Okay, so 4 trees, 2 of each of the 2 varieties will be assigned. Okay, so there you go. So to me, that's something that was a major reading issue. You had to really understand how they were designing this experiment, because I have every trust in the world that you really understand where the better place is to put these trees, you know, but seeing how they designed the experiment really made a difference in which block we chose. So our answer is this. So which is better, A or B? Why? Okay.
Each tree gets put for sure both. Yeah.
Okay, good. Okay, explain your answer. A, so that we can ensure, is that I-N-S-U-R or E-N? We can ensure that both types of trees experience the plots near the forested area. And, you know, we might even say, since the forested area is probably going to have particular qualities that we need to, what are we trying to do? Reduce? Reduce confounding variables, right? And what are the confounding variables? Different kinds of shade, different kinds of nutrients, because you got, you know, foliage that nutrients or takes away at the roots, okay? All right. Even though the students have decided to block, they must randomly assign the varieties of fruit trees to the plots within each block. What is the purpose of this randomization in the context of this experiment? So they're saying that they would randomly pick this one, and then randomly pick this one, and then randomly pick this one, and then that would be the leftover. No, you can't get 3 F1s and 1 F2. No. So yeah, it's like, so I have a container, and I have 2 F1s and 2 F2s. And I need to assign one of those F1, or I need to assign one of the trees here. So how would you probably do that? I'd probably number the trees 1, 2, 3, 4, and then use a random number generator and decide which number went here. And so, you know, the trees are going to, who knows how they're going to end up in this order here, which I kind of disagree with that. What's the purpose of this randomization in the context of this experiment? Okay, I love that. That's awesome. In fact, high five right there. What's the purpose of randomization, period? Randomization will reduce bias created by confounding variable, or wait, created by, who would have the bias? Maybe I really like fruit tree 1s, and I want to put them where I think they're going to get the best, and so I'm going to put them out here where they're going to get the most sunlight and not in here or something, you know, whatever. So randomize will reduce bias. And I guess, you know, created by the planter, I don't know. Yeah, so we'll reduce bias and take away effects of lurking variables or confounding variables. Yes. So take away is too strong, I should say, to reduce the effects. Okay, good job. Here, you get this for a few seconds. Yay. For coming up with that randomization. What's the purpose of randomization? Reduce bias. Okay, good. Good job. And then you did the good wording right there. Okay. All right, so let's see what the answer key says. Blocking scheme A creates homogeneous blocks with respect to forest exposure, sunlight, blah, blah, blah. Okay, I don't really like the way that they said that there. Randomization, look, randomization reduces bias, and in this case, the randomization of individual types of trees to plots equalizes, so we said reduces, and they said equalizes, reduces the effects of other characteristics. So probably I should have elaborated on this in context. Lurking variables such as sunlight, because we always want to put context in there. Sunlight, soil, pH, you know, whatever. Okay, very good. Let's just look at one of the scoring guidelines is going to be exactly what was down there. So let's look at a sample student response. And when you pull this up at the college board, they give you options like I could look at two of them that are scores of 4, and one of them is a score 3. I'm going to look at the one that was a score of a 4, and we're going to go down here and see. Oh, so this is the person's response. So let's read it. Scheme A is better. In B, each block still has a clear gradient in proximity to the forest, which could act as a confounding variable. In A, all the plots in each block have essentially the same proximity to the forest. Okay, so we're going to put all the blocks. So that's saying that we put everyone in block A had the same proximity to the forest, and everyone in the next one had the same. Okay, so I like that. Reducing the variation caused by that factor. Okay, good. And then, let's see what. Randomization will decrease the effect of uncontrolled for differences between the plots. Some plots may generally be better growing sites than others for a variety of reasons, but if the trees are assigned to their plots randomly, these inequities will hopefully be distributed more evenly across the two varieties and not confound the experiment's results. Okay? Nice. Let's take a look at this one. I think I liked this one better. Oh. Is this? Yeah, hold on a second. I think that could be in score the third person. No. Ah, here it is. I don't, probably. Blocking scheme A is more appropriate because it provides for the samples of equal amounts of each tree type in both the trees, okay? Here, I won't read through that. If all samples of the same variety, okay, so you got that. And then in the second one, again, she said this. The purpose of the randomization is to ensure that the conditions for each tree are not manipulated by the experimenter. So that was good. Because remember I said so that we're not having bias towards what tree gets the best situation if we think there is some. This right here is good. Randomization evens out these factors and allows for the experiment to be unbiased. Okay? So that's all good. I can tell you that that one that they said B was it, it's going to go down there. Guess what? Why did they get a 3 instead of a 4? Because they said B is better. So they probably misunderstood it like we did. So even if you had done that, we still had probably everything right here on type A and B, except for we just really kind of misunderstood the representation, and we still got a 3 instead of a 4. That's not bad. Okay? So that would not have killed you. Out of 4. Out of 4. Okay. So because you described everything correct, even though you made that one little wrong choice because you may have misunderstood, you know, this section here, what it was saying, you still only missed 1 point. That's fine. Okay, here we go. Next problem. This might not completely finish, but here we go. Researchers who are studying a new shampoo formula plan to compare the condition of hair for people who use the new formula with the condition of hair who use current formula. So we're comparing a new against the current. So that's an experiment. How many treatments do we have? 2, the new and the old, or current. 12 volunteers are available to participate in this study. Information on these volunteers is this. Okay. Type A says these researchers want to conduct an experiment involving 2 formulas, new and current. They believe that the condition of the hair is changed by age, but not gender. So then how are you going to group them if you think the condition is changed by age and not gender? You're going to put what? Yeah, you're going to make pairs. Because the researchers want the size of the block of the experiment to be equal to the number of treatments, they will use blocks of size 2. So we're going to make blocks of size 2, and how are we going to decide who gets in the block? No, we're not going to randomize because we're blocking to reduce variation. Correct. In this part A, we think people of the same, that age changes the results of the shampoo. So who would I block together? Person 1 and person, okay, 2. Okay, and then what else? How about 10 and 11? And so on. So you're going to group them by age first. How are you then going to assign who gets what treatment? Okay, how are you going to randomly do it? Okay, you're going to look at this block right here, and you're going to flip a coin and give the person the lower number the new treatment, or the one who got heads, or whatever. Give this person, give the number 1, heads gets the new, and tails gets the old. Okay, so there's that. Now look, it says, give the criteria you use to form the blocks. So you're going to have to write besides showing who you group together, make a little statement about it. Okay? Now, let's look at part 2. B says now they want to do it by both age and gender. So now, how would we do that if we were going to do it by age and gender? Who would get grouped together? So, who are the 2 closest females? Number 2 and number 10. Okay, so number 2 and number 10 went together, and then give me the 2, and so on. Males would be number 1 and 11, and so on. Okay, and then you would also write a paragraph that gives the criteria you use to form the blocks. Then the final one says the researchers decide to select 3 of the 6 blocks to receive the new formula and give the other 3 blocks the current formula. Is this an appropriate way to assign the treatments? So is that correct to say, let these people get the new, and, or whatever the numbers were, and these people get the old? Is that the correct way to do it? All of these people get the new, all of these people get the new, and all of these people get the old. Is that the correct way to perform this experiment? Why is that not good? Yeah, because you have purposefully paired up people. So you want one person to get the new and one person to get the old. One person to get the new and one person to get the old. One person to get the new, one person to get the old in each pair, because you've purposefully paired them so they are similar qualities to reduce variation and confounding variables. Okay, so let's look really quickly at a sample student response. Sorry I had to rush through that one, but did you follow okay? All right, they only gave one sample that got a 4, and here's how this person did this. You do not have to provide tables, but sometimes that helps. This person showed how they blocked them up, and then they said, age was used to form the blocks. Similar ages were blocked together. If you left off this statement right here, then you got knocked down from an E to a P. Yes, duh. It's kind of like you need to state the obvious, okay? I can tell that you put similar ages together, but tell them how you did, because they said describe the criteria. So that was good there. Next, for part B, they did the same thing. They grouped them. Blocks were composed of volunteers with the same gender, and similar age. And that's all you need to say. And, of course, showed how you blocked them. Okay? Next. This method is not appropriate. One volunteer from each block should be randomly assigned to the new formula. Notice how they even said this, randomly assigned to the new, and one from each block would receive the current. Okay, random assignment should be conducted, blah, 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 blah. Okay, first number, and so then they described how they did it. They did it with a number generator. I think a coin thing is equally easy. All right. So on your homework, what I want you to do is not everything, because that's a lot, but it's all there if you want to do it. So I want your homework that is due tomorrow and we will quiz on to be this 2005 free response problem. And I want it to be the 2006 free response problem. And then on your multiple choice, I want you to do the odds. Okay? So I would expect that to take you about 45 minutes to an hour for all of that if you do it thoroughly.